So today we will discuss about Gumbel's equation. So till now we were trying to find the probability of some discharge. We were trying to find the probability of a discharge or rainfall or any event which is a part of a series of events. So if you were given suppose 10 or 100 number of discharges, suppose the peak flow of last 10 years, then with the help of that Gumbel's formula we can find the probability of those events in the next t years. So this t is actually, as you know, the return period of the events. So what is t? T is actually 1 by p. But now if I want to do the reverse, that means I know what is the probability of a discharge, but I want to know the magnitude of the discharge. Then what to do? So in the earlier studies, in the previous classes, we have discussed that magnitude is available. We have to convert it into its probability or its return period. But now we will study how to reverse this thing. That means we have the probability or the return period. You want to find the magnitude correspond to that return period. Okay. So for this, there are various methods available, but among all those methods, the Gumbel's equation is widely used to solve this type of problems. Okay. So let us take an example and see how we can solve the problem of finding the real magnitude of discharge or any events whose probability is known to us. So how to do it? Now in this case, so the problems will be like this. Suppose the peak flows of the last 10 years are given. Say for example in the year 2021, the peak flow was 235 meter cube per second cubic. In case of 2020, peak flow was 135 meter cube per second. In case of 19, it was 100. In case of 18, it was again 120. In case of 17, it was 230. These are all arbitrary values for demonstration only. For 16, it is 70 or 700. In 15, it is 500. In case of 14, this is reduced 135. In case of 13, it is 100. In case of 12, it is 90 only. So here you see last 10 years data of peak flow. Peak flow means the maximum flow observed in that year. Okay, so these are given to you. Now the question is asked that the question is like this: what is the magnitude of discharge? Okay, what is the magnitude of discharge uh, for a return period of, suppose, 15 years? So what it want to know is that what will be the discharge, magnitude of discharge for a certain event that has a return period of 15 years. Clear? Now, how to solve this problem? So, as usual, the first step will be to arrange all these discharges. The first step will be to arrange all these discharges, these ones, into the descending order of magnitude. For example, the maximum discharge that can be observed in the peak discharges of the last 10 years for a certain river basin, you can see highest was this 700 cubic, followed by this one 500 cubic, 700 gone, now this one 235 cubic, then this one 230, correct? Then I think these two are same, so these will be 5 and these will also be 5. So 5 and 6 is taken by 5, so next one will be 7. So this is 7, sorry, this will be 7, 120, and this will be 8. Again, this is also 8, so 8, 9, 9 is taken by 8. So ultimately, this 90 is the minimum amount of discharge, peak flow, that is observed in the last 10 years peak discharge data for a certain river basin. So this is the rank of the discharges when arranged in a descending order of magnitude. Right? So the next step is very simple. You convert this into its probability with the help of this formula: P by M, P is equal to M by M plus 1. Or as here the return period is more important, that is why it is better to calculate the return periods of each of these events, which is 1 by P, or M plus 1 divided by M. So you see, let us find this return periods of each of these each of these discharges. So first one, the return period of this 235 cubic, which was the peak discharge of the year 2021. So it has a rank of third when compared with all the other 10 events. Uh, all other discharges available in this set of discharges, third position. So let us see. So n plus 1 means so total number of data is 10. So n will be equals to 10. plus 1, so it will be 11. M is the order of the event. For 235, the order is 3, so 11 by 3 will be the return period. So if I use the calculator, you can see that this amounts to 3.66666. So we can write this as 3.67. Now similarly you can calculate the return period of this event. So it will be 11 by 5. So if I calculate this, so this will be our, let me see. So this will be this 235 as a return period of 3.67 years. This will have a, this one, fifth position. This will have a return period of 2.20 years. So followed by this one, this position is 8. So just 11 divided by 8. So it is 1.375. So it is coming 1.375. So let it be 1.38. Now next one, this one will be 11 divided by 7. It has got the 7th position. So it is coming 1.571. So as the third digit after decimal is less than 5, so I am keeping it like this, 1.57. Right? So next one, this one has a position of 4. So 11 divided by 4 is 2.75. Okay. Then for this one, which has the position 1, so this will have a return period of 11 divided by 1. So the maximum return period will be observed for this event, because this is the event which is highest among all the events considered here. So 11 years. Next one will be the second. Here also what I will do is 11 divided by 2, so it is coming around 5.5 years. For the peak flow or peak discharge of 2014, position is 5th, so 11 divided by 5 is 2.2. It is same as the peak flow of 2020, so I can straight write 2.20 years. This one has a position of 8th, and already we have dealt with 8th, so the peak flow of 2019, so the return period was 1.38, so the same return period will be here, 1.38 years. And lastly, we have a event which has got the last position as per the order of descending order of magnitude. So this will have a value of 1.1 years. So this is the most common event, and this is the most rare event, or the rarest event among all these events. And this is the commonest event among all these events. So you have got all the T's. Now the question is, they want the magnitude of the discharge, which has a return period of 15 years. So now what to do? Your next step will be to find the mean of all these events. So the next step will be uh, so we have find out the respective return period of each of the event. Now our question is that we have to find the magnitude of the discharge which has a return period of 15 years. So for this, what we have to do, we have to first find the mean value, mean of the variate. In this case, the variate is, or x mean is the discharge values. So you have to find the average of all the discharge available in the data set. So data set means this is the data set. This 10 number of discharges is the data set. So you have to find the mean of this data set, and you have to also find the standard deviation of this data set. So the formula of averaging the discharges is very well known. So I have not shown that formula here, but to find the standard deviation of the discharges, we have to use this formula. Okay, Ax is the discharge, Ax is the discharge minus the mean of discharge whole square, and this is actually, there will be a n, and n will vary from 1 to n. So all these values, for example, if I start from 235 minus mean plus then 135 minus mean of discharge plus 100 minus mean. In this way we have to add each of the values after deducting the mean from those values, and ultimately we have to divide that summation by n, which is the total number of data set. In this case it is 10 minus 1, so we have to divide it by 9. Okay, so if I first found out what is the mean of this data set, then what I have to do is I have to add all the discharges available in the given data set. So first is 235 plus 135 plus 100 plus 120 plus 230 plus 700 plus 500 plus 135 plus 100 plus 90. So it is coming as 2345, the summation of all these discharges. Summation of all these discharges is coming as 2345. So here there are 10 data set, so divided by 10, so the mean discharge is coming 234.5. So you have found out mean of the discharges as 234.5. Now deduct this mean from each of the discharges and add the result. And when all the discharges are added in this manner, then you divide the result by n minus 1. By n minus 1, where n is the total number of data set or total number of data available in the data set. Here 10 number of data is given, so 10 minus 1, this will be 9. Another point to note is that after summing all the discharges, you have to square that result and then divide it by n minus 1, and then you have to apply square root to find the final result of standard deviation. Okay, so first step of standard deviation will be to deduct mean from each of the discharges. Then add the result, then add all the results and square it. Then divide it by 9, that is n minus 1. N is the total number of data set, which is 10 here. 10 minus 1, 9. So divide it by 9 and then apply square root on it to find the final value of standard deviation. Okay, so let us, in Excel there is a ready-made formula for finding standard deviation of any data set. So I will use, for time constraint, I will use that formula here. But for solving numerical problems, you have to apply the formula. You have to apply the formula that I have shown you to find the standard deviation. Okay, so let us see what will be the value here. So let us see the values here. Yes, so the first value is 235. Then it is 135. Then it will be 100. So then it will be 100. Then it will be 120. Then it will be 130. Sorry, then it will be 230. Then it will be 700. Then it will be 500. Then 135. So 135. Then 100, and last is 90. So there are 10 number of data set. Correct. You see here are count is your 10. So mean or average is 234.5. You see, this I have already calculated. Now what I will do is I will try to apply the formula of standard deviation. In Excel, if I use the formula STDEV, okay, and select the data set like this, then it will straight away calculate the standard deviation. So this is your standard deviation 2047146. 204, it is 2047146. So third digit after decimal is less than 5, to 204.71, I can say. So the mean is coming as 234.5. Let us apply this average also here. So let us go for this average. So it is coming as 234.5 is the average and 204.7146 is the standard deviation. So you have already found out that this value is 234.5 and this value is 204.71. Now we have to find what is K. K is the frequency vector. In Gumbel's equation, K is solved by applying this formula. K equals to Y minus Yn mean divided by Sn. So what is this Yn? Correct? Yn is known as reduced mean. It depends upon the total number of data you have in your data set. So reduced mean, don't worry, this reduced mean can be found out for a certain number of data in the data set with the help of this table. With the help of this table. You can see this table, I think. So this is the table I will start. Correct? So this is the table I am talking. So this table is, you see, it is showing you the reduced mean and the reduced standard deviation. Here this is sigma n, shown as sigma n, but this Sn is equals to actually sigma n. This Sn and this sigma n is same. Both are the reduced standard deviation, and this Yn bar and Yn bar is same. Both are those reduced mean. Okay, this Yn is reduced mean, this sigma n is reduced standard deviation. And this can be found out with the help of this chart or this table, where the total number of data that is available in your data set. Suppose for our case, there are 10 number of data available in the data set. So you see this n is the total number of data that you have. So for our case, it is 10. So what we'll do is, you see, this is 10, and for 10 number of data in the data set, the reduced mean will be 0.4952 and reduced sigma or reduced standard deviation will be 0.9497. From this table, you can easily find it out. So this Yn bar for the reduced mean becomes 0.4952, 0.4952, and this reduced standard deviation becomes 0.9497. From this chart, you can easily find it out. Now the remaining one unknown variable is this Yt. So how you can find this Yt? You can find this Yt by applying this formula, that is log normal on log normal of t by t minus 1. This can also be written as this 0.834 plus 2.303 log of log t by t minus 1. So here we want to know the magnitude of the discharge. So here you see you have to use this formula to find Yt, because you know what is Yn bar and Sn. These two are known to you, reduced mean and reduced standard deviation. Now you have to know what is Y subscript t. Now this Y subscript t can be found out by log normal of t by t minus 1. As you know, this T is return period. We want to find the discharge of an event which has a return period of 15 years. So this T will be 15. So this entire expression will become 15 by 14, T minus 1. So 15 by 14. So log of that. So what will be the log of that? Let us see. So you can use Excel or you can use your scientific calculator for this. So here, first of all, try to find out what is 15 divided by 14. Here you see it is 1.15 divided by 14 is 1.07. So as the third digit after decimal is less than 5, that is 1. So I keep the first two digits as it is, 1.07. Originally it was 1.07142 and all this thing. So now what I'll do is I want to find the log normal of 1.07. So you can use the scientific calculator for this. Okay, so let us see what will be the value. So log normal of 1.07 is coming at 0.067658 and so on. So as the third digit after decimal is more than 5, 7, so I will change the second digit at 7 from 6. So the log normal of 1.07 is 0.07. Actually, it is originally it is 0.067, but as third digit after decimal is more than 5, so I change this digit as to the next higher one, 0.7, and round it up like that. So log normal of 1.07 is 0.07. Now we have to again apply another log normal. So log normal of 0.07 will be, you see, log normal of this one, 0.07 is coming as minus 2.659. So let it be minus 2.66. Okay. So yt is coming as minus 2.66. So what we do, this is the expression log normal of log normal t by t minus 1. T is the return period. In this case, 15 is the value of return period because I want to know the magnitude of the discharge for an event which has a return period of 15 years as per the question. So t is 15, t minus 1 will be 14. So log normal of 15 by 14 will be 1.07. Again I apply log normal and I have found, t by 15 by 14 is 1.07. I apply log normal on 1.07. I found this 0.07. Now what I do, I again apply log normal because log normal of log normal t by t by 1 is yt. So we again apply another log normal on 0.07 and we find the value as minus 2.66. Yes, minus 2.66. Why it is? Actually, it is minus 2.6592 and so on. But I want to keep the numbers short, so I will keep just 2 digits after decimal. So as the third digit is more than 5, I change this second digit to the next higher one, so 2.66. So that is why it is minus 2.66. So now you find this yt as minus 2.66, yn subscript n bar, the reduced mean is already found out as 0.4952 divided by this reduced standard deviation, which is equals to 0.9497. So let us see what is the value coming out of it. Correct. So here first what I'll do, so I'll put minus 2.66, again minus 0.4952, okay, then I will divide it by reduced standard deviation, which is coming at 0.9497. Okay, so it is coming as minus 3.322. Okay, so here you see the value of k is coming as minus 3.32. Okay. Okay, so you have already now what happened? Now you have all the values of this expression. This one, xt, as you know, xt is equals to x bar, that is mean of the variate, plus k sigma n minus 1. This sigma is actually the standard deviation of the variate. Already we have calculated that mean of the variate is 234.5, standard deviation of the variate is 204.71. Okay, so you see what will happen is here ultimately you see now k is minus 3.32, correct? So let us use Excel here for ease of understanding. So let us say what is mean of x? 234.5, correct? Now minus within bracket value of k is, oh, sorry, this is not minus, it is plus this is 3.32 is the value of k, minus 3.32 is the value of k, and you have to multiply this with the standard deviation, which is equals to 204.71, correct? And what is the value coming? You see minus 445.137. Now remember, this xt is actually absolute value of xt, correct? So whatever may be the sign, you will take the numbers only. So here it is minus 445.137. You will take this as only 445.137, as this xt is actually the absolute value of xt. So here your xt is coming as minus 44.137. So if we apply the absolute value or mod value, that means you will just take the magnitude, you will ignore the direction. So it will become 445.1372. So answer to this problem, what will be the magnitude of the discharge, which has a return period of 15 years. If this is the data set given provided to you will be 445.1372. 445.1372. So this is when you apply Gumbel's equation. So if I summarize every step, then let us see what is in the summary. In summary, what I can say is the question is like this. You have been given 10 or the peak discharges of the last 10 years, like this. These are all the peak discharges of the last 10 years. Now your question is, the question is that what is the magnitude of discharge which will have a return period of 15 years? Correct? So this problem can be solved by Gumbel's equation and many other types of equation. However, if you use Gumbel's equation, the formula is like this. This xt is the value of the variate. X is the variate, which in our case is discharge, and the subscript t indicates the return period for which we want to know the magnitude. That means for this problem, we want to know the magnitude of discharge that has a return period of 15 years. So this is actually indicate that we want to know the x at 15 years. Okay. So for that, what you have to calculate? You have to calculate the mean of the variate. That means you have been given 10 number of data. You have to find the mean of this data, which you found out as 234.5. Then you have to find out the standard deviation of this data, the same data, with the help of this formula, sigma n minus this one. This is very common formula. Now, after we have found out the mean of the data, that is mean of the variate, which in our case is discharge, and you have been given 10 number of discharges. So you have found out the mean, you found out the sigma. This is first step. Second step will be to arrange this discharge, the given discharges, into descending order of magnitude. That means the highest value will get the best rank and the lowest value will get the worst rank. So here you see this is the highest value, 700 cubic meter per second. So this was given the best rank, 1. And this 90, this is the lowest value. So this was given a value. This was assigned a rank of 10. This is the worst rank because there are 10 number of data. So maximum rank that data can be assigned is 10. Okay? And then you will use the formula P equals to m by n plus 1, that age-old Gumbel's formula, to find the probability of these events. Or as we are dealing with return period, you can straight away calculate the return period, which is just the inverse to the probability. So if P is equals to m by n plus 1, then T will be equals to n plus 1 by m. Correct? Now, in the step 2, actually, what you have to do is you have to find out the return periods of each of the event given in your data set. So you have been given 10 number of data in your data set. So you have to find the corresponding return period of all those 10 data. Clear? After you find out the return periods, what you will do is, let us return to this equation, xt equals to x mean plus k sigma. At the first step, you have found out the mean and sigma, that is standard deviation, but this k is unknown. How to find out k? K, the formula is given here, k is equals to yt minus yn bar divided by sn. What is this yn and why this sn? These are known as reduced mean. This yn is the reduced mean and this sn is the reduced sigma. This is a function of total number of data given to you for a problem. So in our case it is 10. So a table will be given. So first we'll find out what is the total number of data you have. In our case it is 10. So this column n will hold the total number of data. This column yn bar will hold the corresponding reduced mean, and this column sigma will hold the corresponding standard deviation. So for 10 number of data, the corresponding reduced mean is this and corresponding sigma is this. So straight away you can find out the value of yn bar and sn. Okay, this sn is same as sigma n and this yn bar is same as yn bar, this yn bar. And this table is also known as let us say, so this table is also known as the Gumbel's extreme value distribution table, or reduced. This table is also known as reduced mean and standard deviation in Gumbel's extreme value distribution. So this table can be in some problems reduced mean and reduced standard deviation is given in separate tables, and in some problems both are clubbed in the same table, just like us. Okay. So this is actually the reduced mean and reduced standard deviation in Gumbel extreme value distribution. So after then, when you find out the reduced mean and reduced standard deviation, so you can find that to find k, you need to find yt, y subscript t. So for finding y subscript t, you have to use this expression. This is log normal of log normal t by t minus 1. T is the return period for which you want the magnitude of the discharge. This is the return period for which we want to know the magnitude of discharge. So in our case it is 15 years is the return period for which we want to know the magnitude of discharge. So t will be 15. So 15 by 15 minus 1 is 14. So 15 by 14, we have found that it is 1.07. You apply log normal on that 1.07, you will get 0.07. If you again apply log normal on it, you will get some negative values, and this negative value will be minus 2.66. Okay, so if you found in your calculator that the numbers are 2.65566678, so very large number after point, then you reduced it up to 2 digits after decimal. If the third digit is more than 5, then you increase the second digit to the next higher number. If it is less than 5 or 5, then if it is less than 5, then you keep it as it is, the second digit. If it is 5 or more, then you change the second digit to the. Okay, so this way what we found is it is 2.66 minus 2.66 is the value of yt. Now in this expression, k is equal to yt minus yn bar by sn. All the values are now known. Yt is minus 2.66, yn bar is 0.4952, sn is 0.9497. And then you can find out that k is minus 3.32. So the only unknown value in this expression after step 1 was k, and k is k is what you find is 3.32. So put the value of k0 minus 3.32 on this expression. So here x is 234.5, calculated step 1. Sigma is 204.71, calculated in step 1. And k is 3.32, calculated in the previous step, minus 3.32. If you put all these values into this expression, then you will find that the magnitude of discharge for a return period of 15 years, that means x15, is equals to minus 445.1372. Now, as this x15 is the mod value of x15, so you can easily cancel out the sign, and you can say that magnitude of discharge for a return period of 15 years is equals to 445.1372. So this is what the Gumbel's equation with which we can find the magnitude of a discharge if return periods are known to you. Thank you.